Welcome to my channel class 7. So today we are going to start the second part of this chapter, the elements, compounds and mixture. Okay, so we have already discussed about what is element, what is compound and what is mixture. Okay, now when there is some mixtures, okay, there are many types of things, substances together, so we need to separate. Sometimes we have to separate. Now see the example here. There are some rice and some dal is there, okay, some husk is also there, stones are there. So if we have to remove all the particles, means especially the husk and the stones from our food, then what we have to do, we have to use some methods. Okay, so what were their methods and why we use these types of the separation of the components of the mixture? So always we have studied about desirable and undesirable change, isn't it? So can you see what is this change? This is obviously a desirable change when we have to remove some unwanted substances from our food. Next, have you seen this picture also? Here some stones and rice is shown, isn't it? So we have to do it. So we have to separate the unwanted stones from the rice. But how it happens? Obviously your mother, I think at home, what she does while bringing the rice bag from the market, then she will sort out all the unwanted things from the rice and then she will cook the food for you. Okay, so she will use mostly the hand picking method. You know what is hand picking method? One by one, with the help of the finger, she will remove the stones. Okay, this is a figure of hand picking. So these are also some methods, but nowadays whatever the packed rice we get, so all are neat and clean. Obviously we get the all packets neat and clean, but surely homemaker always she tries to check if there is any other stones or unwanted things in the mixture. Then there second diagram, can you see what is this? Okay, here what happens, the wind will what will the wind will do? The wind will take away the husk. Okay, and it is done in the paddy field. Next is the sieving. We use this one when we use the flour. The flour, when we sieve it, okay, this is known as sieving. We separate the unwanted things from it. Okay, next is the threshing. Threshing, you know what is this? It is also done in the paddy field. So what is done here? So when the together they will take a bunch of the paddies, and what they will do, they will beat in a stone or any log. Then the grains will be separated from the sticks. Okay, so now there is a need of the separation method, and what are the needs? Let's see. So most substances that are found in nature are mixtures. Air, sea, water in the reservoirs and crude oil are all the mixtures, and to get better substances found in these mixtures, we need a separation method or a technique. So there are few separation techniques. What were they? Evaporation, distillation, use of separating funnel, sublimation and fractional distillation. These are in order to separate the undesirable substance from the mixture. Now here the separation we will study from solid to solid or solid to liquid and liquid to liquid mixtures. Okay, so we have to separate this things one by one. In class 7 course you will get this, but in higher classes you will get from solid to gas, how it is to be separated, from liquid to gas, what, and from gas to gas mixture. Here we will study about separation of solid mixture first. Okay, let's see the example of the sublimation. Sublimation is what actually? This is a process, okay, that involves transition of solid phase directly to the gaseous phase and which doesn't enter to the liquid phase. Okay, so here dry ice in the example. Dry ice is also a solid carbon dioxide, CO2, and carbon dioxide is typically found as a gas, and when it is frozen into a solid, it turns directly into gas and totally skips the liquid stage. So this is an example of a dry ice. So there is an experiment here given to you to separate a mixture of one common salt. Okay, there are the here it is given about ammonium chloride. Okay, ammonium chloride and the common salt. So here it is a mixture in the china dish. I think you can see lower is a burner. So in china dish there is a mixture of the ammonium chloride and the common salt. So what we will do here, we'll take this mixture and in the watch glass. This funnel is a watch glass. Okay, then we'll cover the watch glass with the funnel and in inverted position, and in inverted position in the upper position we'll keep one cotton plug. Okay, then when we'll heat it, we will see some white fumes will be condensed along the upper part of the funnel, means where it is a little bit cooler there. Okay, which will remain in the watch glass. Now what we'll find that ammonium chloride has sublimes on heating, where the common salt does not. Ammonium chloride will heat it up, okay, as it is a sublimable solid. What is sublimable actually? Ammonium chloride is said is sublimable solid because it will directly convert into gaseous, okay, without entering the liquid phase. So what will happen here? The common salt will be in the china dish, and ammonium chloride will be collected. When the solidified ammonium chloride will be there in the neck of the funnel, then we will be separated by the process of the sublimation. So this is the process of sublimation. Next we will talk about the separation of solid and liquid mixture. This one was solid, both were solid, common salt and ammonium chloride. Now we will talk about the solid and liquid mixture. Here first experiment will go. Okay, what is this? Actually there is a glass of water and here it is a spoon of salt. So here solid is a salt, common salt, and liquid is what? Here the water. So when this two will be a mixture, now this is a solid liquid mixture, we will use the separation of evaporation. So what is evaporation? What we will take, see in the diagram, there is an evaporating dish. Okay, there is a mixture of the salt and water is there. What will happen? Slowly the water will be evaporated up. Okay, the water will be evaporated, and as the water will be heated, the salt solution will be left on the evaporating dish and salt crystals will be there, and others the water will be vaporized up. Okay, this is the process of the evaporation of separating the mixture of solid and liquid. Here solid was salt and liquid was water. Next we'll talk about this diagram. This diagram will give an idea of the distillation. But now we have to see one by one what are the parts of the what parts are there. And distillation is what? This is a process of which involves the separation of pure liquid, okay, from homogeneous solid and liquid mixture. Okay, so here same salt water or sea water is taken. Okay, Bunsen burner is there, one clamp stand is there. Now as there one thermometer is also there, isn't it? Distillation flux is there. Then this distillation flux is connected to the Leibniz condenser. Liebig condenser is nothing but where one cooling water is also there, means one side water will be out and one side water will be in, because to keep the condenser cold. Okay, then there is a funnel to the receiving flux there, distilled water is there, means condensed water. Okay, now what we will do here, we have taken everything. Distillation flux is taken, condenser, thermometer, receiver, tripod, wire gauze, burner and tap water is taken here. Okay, now what we will do, we will heat the distillation flux containing the tap water, and when this distillation flux will be heated up, water vapors will rise and it will go to the Leibniz condenser, and water drops will be fall in the conical flux. When this water evaporates and condenses, then it passes through the Leibniz condenser, leaving behind the salt in the distillation flux. So in the distillation flux the salt will be left, and through the steam and through the Leibniz condenser, the steam will be cooled in the Leibniz condenser, because cold water is in and out, and it will be received in the receiving flux. Okay, so this is a process of the distillation to separate the solid and the liquid mixture. Okay, next we will talk about the liquid mixture, separation of liquid mixture. Here what happens, there is we will use the, what is this actually? This is nothing but the acetone. Okay, when acetone is added to the water, what will happen here? Both are liquid. Acetone is also a liquid, water is also liquid. Now I am saying about acetone. What is acetone actually? Do you know what is acetone? First main use of acetone is, it is used as a nail remover also, means this is a spirit like an alcohol. Okay, this is a spirit. So what will happen here? Here all the content, means these all the nail acetone will be added with the water. So let's see what is fractional distillation here. In fractional distillation, same distillation flux will be there. We are taking here acetone and water, both are liquid mixture. One clamp is there, fractionating column is there. Okay, there is some thermometer, cork is also there. What same Liebig's condenser is there. Okay, where water, in the water condenser there will be water in and out, and we will collect the acetone in another flask. What we will do, when we will heat the mixture slowly, we will keep a close on watch on the thermometer. Okay, always will remember that first the acetone will be vaporized first, and then it will condense in the condenser and gets collected in the other condenser, means it will be on the another container. Okay, and when water will be left behind. Okay, first as acetone is a spirit type. Okay, so it will be by thermometer we can see that before boiling point of water is 100 degrees Celsius. So before 100 degrees Celsius the acetone will be passed through the steam, and it will be cooled and it will be collected on the other condenser. So this is a process of how to differentiate, how to separate the liquid mixture. Okay, next we'll talk about the separation of two immiscible liquids. Here also it will be liquid only, both are liquid. Now by this diagram, can you see what is this actually? This is a proportion of, means a liquid of oil and water, isn't it? We can see in where water, oil always floats on the water. Okay, so how to separate them? This methods, okay, is used by the separating funnel. So what will be there in separating funnel? In separating funnel, we have taken there some kerosene, oil and water, and a stopcock is there. Okay, will not disturb the funnel. We'll keep it straight. Okay, till the layers of the oil and the water can be felt. Okay, we'll just keep it there. Then slowly what will happen? After some time, the dense liquid will be form a layer there, one lower layer, and one which is less dense will be in the upper layer. Then we'll just open the stopcock. When you open the stopcock, what will happen? Slowly the water will be go out. Okay, and the as we will reach the line of that kerosene oil, then we will stop it. So as water is denser than the oil, so what will happen? Here oil is lighter than the water, so it will float as a layer, and in that layer we can stop the cock, and we'll get the separation of the both immiscible liquids. Acetone and water was miscible liquids, and here it is kerosene, oil and water is an example of the immiscible liquids. Now there is one more mixture of more experiment of separation technique is there, that is known as the chromatography. Okay, so chromatography, here two words came here. Chroma means color and the graphy means writing. Okay, so chromatography is nothing a physical process, and which will separate the components of mixture based on the selective adsorption or surface absorption it will be. So what we will do here, we will have to take one paper. That paper chromatography involves a very fine grit filter paper known as a Whatman number 1 paper. Okay, this is a Whatman number 1 paper. Okay, here this paper will we have to use as in the paper chromatography, and also we will need a pen ink black color, mostly a marker pen of black color. Then we'll have some solvent. The solvent is a water and 10% alcohol will be there. Okay, and next there will be a glass jar. Okay, so these 4 things we are needed for a paper chromatography. Okay, so what will happen here? Then we'll first, in the first diagram, see here it is tied in one plate there. Okay, the Wattman paper is tied there. Then we'll draw a horizontal line on using the pencil. Okay, above 3 centimeter above the lower edge. Okay, one just a line will be there. Then we'll put some small drop of ink on the center of the line and we'll let it dry. After it is dried, then we'll place the paper on the glass jar where the solvent is there. The solvent must be in the just above the level of the that line. Okay, then slowly we have to record our observation. When we observe that, we'll see the different colors of ink get separated at different distance. Okay, from that black color, slowly it will be a surface absorption, and from that black color many colors we will get it. Okay, now here solvent is a mobile phase and Wattman paper is a stationary phase, and here the capillary action is done and solvent moves up the paper and components of the mixture are carried along with the solvent to varying degrees. Means all color have different degrees depending on the selective adsorption. Okay, so here the component that is more soluble in water rises faster, and in this way the colors get separated. So from black color we can get different types of color. Okay, so this is a paper chromatography. Applications of paper chromatography and why we can use the paper chromatography we will discuss here. We can use a paper chromatography to identify the constituents of a mixture, separate components of natural pigments like chlorophyll, separate amino acids, identify organic compounds and biochemical in urine, and determine hormones and drugs in pharmaceutical sector. So these are the applications of the paper chromatography. Now from this book which I have preferred for, it's all about science, chemistry, class 7, H1 school book. Here in the page number 56, checkpoint is given here. Okay, so the first checkpoint here, question answers are given. The first is what? Name the technique that you would use to separate the following mixtures. So which technique we will use? Okay, the answers are given to you. The first was iodine and alcohol. Iodine and alcohol, here the technique that we use to separate this mixture by distillation. Then number B, the mud and water, the technique that we use to separate the mixture by filtration. This is by also filtration. Okay. Then number C, the technique that we use to separate the mixture of oil and water. This mixture is by separating funnel. So next we'll go to question number 2. Here we have to state the principle of underlying the following technique. So what is the principle? Number 1 is 2A, fractional distillation. Here the principle of fractional distillation is that different liquids boil at different temperature. The miscible liquids boil at different temperature and evaporate at different temperature. Number B, 2B is use of separating funnel. Separating funnel work on the principle that immiscible liquids will separate from each other naturally along with the solutes, creating different layers of solution solute. Okay. Then number C, filtration. Filtration is commonly the mechanical or physical operation which is used for the separation of solids from fluids, liquids or gas, by interposing a medium through which only the fluid can pass. The fluid that passes through is called the filtrate. Then 2D is sedimentation. Sedimentation is a tendency for particles in suspension to settle out of the fluid in which they are entrained and come to rest against a barrier. Okay, then number 3 question, what is given here? How we can separate a mixture of two miscible liquids? How? Fractional distillation. Okay, is used to separate two liquids which are miscible and which boil at different temperature. The use of fractionating column in the distillation apparatus, where the temperature varies, vapors of the component with higher boiling point condense at the bottom, while vapor of the component with lower boiling point rise to the top of the fractionating column. Okay. Number 4. How can we separate a mixture of salt and ammonium chloride? Obviously, we have studied just now. We can separate this mixture by what? Sublimation. Sublimation is a process that involves transition of solid phase directly into gaseous phase without entering into the liquid phase. Now number 5 is what? Is the dye in black ink a single color? Justify your answer. No. The dye in ink is black ink is not a single color. The process of chromatography is a justification of this statement. So we have already discussed this experiment and diagram is given to you. So you have to justify this answer by you have to explain the experiment and with the help of the diagram also. Okay. So till then, thank you. Rest exercises will be given to you very soon. Thank you. Goodbye.